everyone. I am Sanchana. I'm a graduate student in CU Boulder, and I'm presenting our project, which is Employee Attrition Analysis and its Predictability. First, let's discuss what attrition is about. Attrition, which is also called employee churn, basically means that the employee are voluntarily resigning the company. This happens two way, which is voluntarily and involuntarily. Involuntarily is when the company lays off their employees, and you should be aware of that because the situation that we are in, we would evidently witness a lot of it. So that is one type of employee attrition. Attrition is a problem which impacts all the businesses, irrespective of its geography, industry, or the size, and it disrupts the workflow when it is actually done voluntarily. And it leads to significant cost for the business because they need to hire and train the talent people. And the cost for the attrition can be ample. And this is where ML or machine learning helps us. So we will be able to predict who the people are likely to churn and what are the factors which are causing that. So in our project, we would be analyzing those factors and tell how and why is that factor affecting the attrition. And as a result of the analysis, we would be able to recommend the HR department a plan which will help them be prepared for the situations like this. Yeah, moving forward.
Yeah, I'm Omsai. I'll be presenting data preparation and univariate analysis of this project. Yeah, coming to the data, we have taken this data from Kaggle. Actually, this data was collected by IBM and made available open in the Kaggle. This data set doesn't have any null values pretty much, so there isn't anything that we had done to remove null values. Just we check the null values. Next slide. Yeah, there are 4 columns which are seem to be redundant. These 4 columns are dropped, and we prepared our data. These 4 columns are like over 18. Since most of the employees are above 18 years old, so there is no requirement for this column. And the employee count same. There is no requirement of with this column. And the standard hours and employee number also redundant, which doesn't impact the attrition target variable. And post completion of our data preparation, we have about 31 columns and 1470 rows. Next slide. Yeah. Coming to the univariate analysis, yeah, these are the categorical variables on which we have performed univariate analysis. Coming to the attrition, this is our target variable. By seeing this plot, we can say that this data set is completely imbalanced. Since 83% of the data is classified as S and classified as attrition to S, and only 16% classified as no. So we have to perform we have to balance the data set through different sampling techniques. And coming to the marital status of the employee, about 46% of the employees were married, and 22% of the employees were divorced, and 32% of the employees were not married actually. And coming to the department distribution, the research and development department are the most of the people who got churned. Maybe it may be because of the infrastructure or any income related issues. Coming to the travel distribution, most of the employees doesn't travel frequently, they travel rarely. And the next slide. Yeah, I have explained these points in the previous slide. Yeah, coming to the numerical attributes, yeah. We have observed distance from home distribution to be somewhat skewed. From this distribution, we can say that most of the employees are very close to their working place, and they don't have to travel a lot. They don't have to travel so much distance to reach their workplace. And same, if you go to this work years in current role, most of the employees are not don't have so much experience. They're not been in this role for so many years. And coming to the daily rate, we can see that the data is not distributed normally. By this, you can understand that different range of income people are present in this data set. Same applies to the monthly rate, which is not normally distributed. By this, you can understand that in the data set, that people belongs to different salary levels are present. Next slide. Yeah, completed.
Hi, my name is Sreevani, and I'll be explaining about bivariant data analysis. So coming to the first part. So here I'll be explaining the comparison of job satisfaction based on time spent at the company. So as you can see in the graph, there is a fluctuation between 0 to 10 years for the job satisfaction rating, and the rating is gradually decreasing, or it's becoming stagnant after 10 years. So this is about discrete and discrete numerical variable. So coming to the next slide, and here we'll be explaining about the discrete and continuous variables. So the first graph shows that the age group between 26 to 40 has majority representation on lower end of the monthly income scale, and the age group between 41 to 60 are equally represented throughout the monthly income scale, while age groups between 18 to 25 and 26 to 40, they reach a saturation beyond the 10K mark. The second graph, this graph suggests that most of the individuals have a moderate work-life balance, where the one indicate the bad work-life balance, and four indicates good work-life balance. And the third graph shows a portion of members with attrition yes category fall under the lower monthly income scale, while some of the members with the attrition no fall under the lower end of the monthly income scale. And the fourth graph explain about the business travel, like people who are earning between 0 to 5,000, they rarely travel. So this is about discrete and continuous variable. Coming to the next slide. So the following heat plots visualize the contingency tables for two categorical variables. So here attrition we have kept constant on a particular axis, and it is compared with categorical variables like business travel, age group, department, job role, and experience level. So when age group and attrition were compared, it was observed that within age group between 26 to 40, a higher attrition rate was found. And it was also observed that the same age group represented majority of individuals with low attrition rate. So this is about bivariant data analysis. So Philip will be explaining about hypothesis testing. Thank you.
Hi, my name is Filip, and I'm gonna talk shortly about hypothesis testing of our project. So the goal of our hypothesis testing is to see what numerical attributes can be potentially good in predicting the attrition value. And since our data population is unknown, we will be using one sample t-test, and we hope that the results of our hypothesis testing are gonna be useful for future modeling, such as regression. So as an example, we can state a null hypothesis saying that there is no significant difference for the mean values of the variable percentage salary hike among the two distinct categories of yes and no in the attrition column. And an alternative hypothesis in this case would be the opposite, would be stating that there is a significant difference between those two subcategories. Here is an example of an R code along with an output. We can see the t-value, degrees of freedom, 95% confidence interval, and the respective means for both subcategories. Since in this case the p-value is low, 3%, falls in the rejection region, we can conclude that the alternative hypothesis is true, and the mean for those two subgroups the means are actually different. Here's another example for a monthly rate by attrition, and here we can see that the p-value is very large, and we fail to reject the null hypothesis. So as for results, we found that there is a significant difference between the means of these two groups for distance from home, monthly income, and years with current manager. On the other hand, the means for monthly rate, percentage salary hike are the same, and there is no difference. So they are probably not as good for predicting attrition value. As for difficulties, I think there are no difficulties in hypothesis testing, and one simple t-test works. The only thing is to set the right rejection region values or the alpha threshold. But we just went with standard 95% confidence intervals, 5% of alpha value.
Hey guys, I'll be explaining the results and findings. So while most of our hypothesis testing, bivariate and univariate analysis did convey certain results, but here are a few things which we found that would be key for the future modeling purposes. So the most important factor for attrition would be the daily rate, which suggests that what would be the rate an individual in a company would be paid, based on which he decides to stay, or further down decides to leave the company. So when we observed the mean daily rate of the people who stayed and left the company, we could observe that there wasn't much of a significant difference between the two groups. So we could say that this there was no major contributing factor from this particular column for the attrition rate. So moving on, we did a kernel density estimation analysis between all the continuous variables. So while we found that most of the distributions, were uniformly distributed, we also observed like a right skewed distribution for certain attributes such as monthly income, percent salary hike, and distance from home. Whereas in few other cases, there was like a bimodal distribution, such as years in current role. Moving on, we wanted to analyze on what factors did attrition highly depend on. So we found that certain variables such as years with current manager, years in current role, and years at a particular company. So from the correlation heat map over here, so they suggested that they had a high dependency on the attrition rate. So finally, as Filip also explained that from the hypothesis testing, we could conclude that where daily rate and percent salary hike, where we failed to reject the null hypothesis, did not play a good contributing role for the modeling purposes, where further we had to rely on variables such as daily rate, distance from home, and monthly income for the modeling purposes. So finally, I hand it over to Pranjal for the concluding remarks.
Thank you. So as you see, the concept of attrition basically refers to an employee, voluntarily departing from a company, and that caused a lot of, loss to the company because maybe that the employee who left may be a high performer, best performer, and that creates a vacuum that it's difficult to fill. So in this whole project, we were trying to estimate the factors that could lead to an attrition, maybe estimate the severity of those factors, and eventually try to build up a prediction model if we could predict it in this aspect. So we did try prediction as well. We tried the logistic regression, trying to predict the labels like whether the employee will leave or not leave based on various factors. So although it is consensus that over the years the dynamics have changed between employer and employee, but still attrition is a big problem right now. And I have my first-hand own experience. Like in my previous firm, my manager was troubling to find people because of that this attrition. So based on our analysis from using the IBM's data for all kind of non-personal identifiable information of past employees that have worked over the IBM that has left. So considering all those factors, we found millennials who a younger generation have the highest attrition rate, followed by those who are approaching retirement. That is expected. But it's surprising, 54% of the employees who had left IBM had not worked overtime. So this was a little different than expectation, primarily because maybe they were underused, and because of poor management, they were not being utilized well. So almost all of our hypothesis tests also had the consensus that the null was rejected, primarily because of bimodal distributions overall. So that is one of the most important reasons. And the other reasons, other big factors, was monthly income, work-life balance, job satisfaction, and age. So these were quite obvious ones. So as of conclusion, this report concludes that these are the factors that the employer should look at. Maybe talk to the people's analytics team, get results from polls, surveys, try to get a feel of understanding from the employee's point of view that what is happening, if the person is being underused, underutilized, do they want more work, and other factors like recognition also plays important roles. So it's a damaging process, and we realized it's so severe, and there are a lot of factors that contribute to it. So yeah.
Hi, I'm Natalia Mora, and I'm going to discuss just a potential next step that goes beyond the scope of this project. So as Pranjal mentioned, we did notice some trends just from our data analysis within this project. However, the scope of this project doesn't include actually building a prediction model. It just provides an in-depth data exploration and data familiarization as framework for possibly future prediction model. And so ultimately, one of the primary motivators for analyzing and understanding employee attrition data would be to discover ways to improve upon employee churn rates. Therefore, the natural next step following this project would be to actually create the prediction model and be able to predict the likelihood of an employee leaving a company. However, the exploratory data analysis explained in this project revealed a clear imbalance in the attrition variable, as we mentioned. And the problem with that is training a model on data whose dependent variable of interest is skewed ultimately leads to skewed conclusions. Therefore, before constructing an actual trustworthy prediction model, the data would need to be balanced using a strategic sampling technique, such as oversampling the minority attrition result. In this example, this would be the yes case, or the scenario where the employee does churn, since, as we discussed earlier, the attrition variable in this data contains a majority no case. And then after the data imbalance is accounted for, an algorithm such as logistical regression could be applied to make predictions. And although formal parameter selection would be required in this case scenario, the possible attribute relationships that we identified in this project through the hypothesis testing could be a good place to start.